All right, so today's Unit 7 review and lesson is actually a couple questions from your previous assessment. So yesterday's video and today's video really kind of covers the first several problems in the first part or standard of the assessment where we were solving linear equations, and now we're solving systems of inequalities. And so the very first one, I ask you to solve a system of inequalities, and these would be any ordered pairs that would make both inequalities true. And so this is going to be a shaded region. So the first thing that I want to do is I'm going to rewrite these in slope-intercept form. So if I rewrote this top one in slope-intercept form, I'd get 2y is less than or equal to, if I subtract x from both sides, negative x plus 2, and I divide both sides by 2. Be really, really careful, because if you divide by a negative number, you would have to flip this inequality symbol around. I do not divide by a negative number, so I do not have to flip it. It's y is less than or equal to negative 1/2 x plus 1. Solving the second inequality, I subtract x from both sides, and I get y is greater than or equal to negative x. So for our top inequality, this has a y-intercept of 1 and a slope of negative 1/2, and it is a solid line. So a slope of negative 1/2 means I go down 1 to the right 2. And I don't have the best axis right here. I use a solid line for this boundary because it's a less than or equal to. If it had just been a less than, it would be dashed. And I'm going to shade either on this side or this side. Some people just can look at the inequality and they say, oh, it's less than, I shade below. I always like to test a point just in case. And so if I put the point 0, 0, 0, 0 is down here. If that is correct, I'm going to shade down here. If 0, 0 is not in the solution, or does not make this true, then that means I'm going to have to shade up here. So I have my point 0, 0. When I put it in, I get 0 is less than 0 plus 1. That is a true statement. That tells me I'm going to be shading below this boundary line. So any ordered pair below that is in the solution set. All right, let's go to our second graph. Y is greater than or equal to negative x. So we can think of this as a y-intercept of 0 and a slope of negative 1. So I'm going down 1 over 1. And again, my graph is not super to scale, but we'll do the best we can. So looks something like this. So we want to make sure we're careful. This really has 4 possible regions. So we have a region here, and that would expand as the lines went up. And then we have the region up here and up here. So keeping track of where I am, this is on 0, 0. So I can't test the point 0, 0 since it is actually on the boundary line. So I'm going to just choose to pick something way up here. I'm going to choose to pick the point 3, 3. That would be up there. So again, this second line, if 3, 3 is in the solution set, that means I want to stay above. And if 3, 3 is not in the solution set or does not make it true, I want to stay below that line. So 3 is greater than or equal to negative 3. Is that true? It is. So I am staying above this line. So very carefully then, the overlapping region would be where these arrows are pointing to each other. And so it would be right in here. Suppose you were given a multiple choice question. If you wanted to make sure that the region shaded was correct, you could simply test a point inside here and it would make both inequalities true. All right, that leads me to question number 2. If the system is y is less than or equal to negative 2x plus 4 and y is greater than or equal to negative 3x plus 2, which quadrant contains no solutions? So first of all, if you want to check, you could simply check a sample point from each of these, or you could try graphing. And here's what I mean by that. If I picked a point in quadrant 1, 2, 2, for instance, and I just looked up here, is 2 less than or equal to negative 4 plus 4? Okay, is 2 less than or equal to 0? So that's true. And how about over here? Is 2 greater than or equal to negative 3/4 x plus 2? Sorry, that should be a 2. And then is 2 greater than or equal to negative 1.5 plus 2 or 0.5? So that's true. So what that means is 2, 2 is in quadrant 1, and it makes both true. So there's going to be some solutions in quadrant 1. So I'm trying to look to see which would have no solutions. So you could go about that method and see if you can find which one does not make both true. And then I'm going to actually show you another way, which is you can graph like we were doing before. So I'm going to go ahead and try to pick a scale and it be as neat as possible. And I'm going to put my y-intercept of 4, and I'm going to go down to over 1. Oh, I don't know if I did that. Okay, so something like this. 0 is less than or equal to 4, makes that true, so it's down here. All right, and I'm gonna go to my other one. This has a y-intercept of 2 and a slope of negative 3/4, so down 3 over 4. All right, so I'm kind of doing an estimate here. And I have 0, 0, and I check. 0 is greater than or equal to 2. 0 greater than or equal to 2. That is false, so I'm shading above this line. Okay, so there's some solutions right here. This is where they overlap, okay? It looks like some of them are in quadrant 1 and some are in quadrant 2. And so there's none in 3 or 4, but 4 isn't listed in my choices. And so it looks like I would have to choose letter C in quadrant 3. There are no solutions. Okay, so there's a couple inequalities problems for you to try, and just keep in mind that we are gonna go through probably 1 or 2 more days, I think actually 2 more days of some Unit 7 stuff, and then I'm gonna give some of you an opportunity to retake.